Hello to everyone. This is our next webinar series from Dexma. This is Daniel Hughes, the product director of the company. And I have today with me two uh, very important guys of the company, which are Juan Fernandez Troyano. He's a data science. Hi, Juan, how are you?
Hello to everyone.
And then I have together with me as well Uriol Serk, the other data science of the company. Hi, Uriol, how are you today?
Hello everyone.
So it's a really nice webinar today because it's our last webinar for this season. So it's before Christmas and we're starting holidays, same as you guys. And I'm very happy to see people from 8 different time zones today connected with us. So that's so crazy. Okay, so in today's agenda, we would like to introduce you about the artificial intelligence and how this awesome technology is going to change the world of the energy management, and as well many other ways on how we see the world today. Isn't it? Right, guys?
Yeah, we're trying to do that.
Good. So I'm not commercial guy in the company, but I would like to introduce you as well, the Dexma, for the ones that I've seen on the webinar registration that you don't know us or you are not still partners of us, right? So at Dexma, we are doing just one thing, which is cloud energy management software. Okay, and our main product, it's called Xcel Energy Manager, and we have been working into that product for almost 8 years so far. Okay, at the very beginning, guys, I have to tell you that it was so difficult. It was very tough. Uh, we had to evangelize a lot the market in terms of which were the benefits of the energy efficiency and reducing the energy consumptions for the wall. Nowadays, the trend is changed a lot, so we are having more and more global coverage thanks to our partners because our product is mainly sell through a network of partners, and you, the partners, are the ones that use our product, our software, to solve your day-to-day problems, to be better at delivering your services to the end customers. Okay, so basically the Xcel Energy Manager is the only SaaS platform for energy management that offers the whole journey. It starts from the detection part, where you don't have hardware deployed on the field, and with our artificial intelligence algorithms, we tell you how much efficient you could be, so how much you could be saving, right? This is without capex, without the need of installing sensors on the field or investing a lot of money. Then if you have the tech that your building is a good building to start saving energy and your customer agrees, then you go to the next step, which is the analyze. And in the analyze part, where you will see today, it's the full bunch of solutions that we will show you today, and most of them are based on artificial intelligence in order to help you scale and detect or try to save energy for your customers. Of course, those customers that they need a step beyond, they can control all their systems using our platform as well. So Dexma today is offering the whole journey inside the energy management projects. Okay. If you have any doubts, just remember that we have the box on the webinar tool where you can ask everything you want to know. Okay. So, well, Dexma, after these 8 years producing this product, we are very happy to have this global coverage. So the product, it's very localized in many different regions around the world. That was hard, but we did it in terms of tariff structures, prices, currencies, and many other differences that we have seen from one country to the other. Nowadays, we are working with a full bunch of partners. Mainly, our operations are based in Europe. Okay, so we have a good bunch of customers in the United Kingdom, in France, Italy, and Europe. It's still our main focus. However, as you can see, we can deliver this solution. We can serve you guys if you are connected from Australia to the United States. Okay. This is just a very small list of our customers today, just to represent that the product is not just focusing one particular sector, but it's transversal. So you can use our solution to provide services to retail sectors, educational, hospitality, telcos, banking as well, museums. For instance, I'm very proud of be the software that is using the British Museum to save energy, by the way. Then the public administration as well, industry. We have a lot of customers that they save energy in industries and partners that they get the value from industries. Of course, energy and utilities as well, and construction and pharmaceuticals. Okay, so the solution is very, very transversal. It doesn't matter the sector that wants to save energy. Okay. Well, this is what the industry experts says about us. There are a full bunch of analysts in the market that they try to rank companies similar to Dexma. I don't know if Dexma is better or not than our competitors. We have many on the market, and we are constantly trying to be the best ones. But that's what they say about us. Okay. And why Dexma is working on artificial intelligence. So why we have to do this? Why it's not just enough with showing data? Because, guys, our experience says that it's not enough. It's not enough just to show data. That's a data platform, but we're going to go one step beyond. And that's what Gartner saw in one of their, or Gartner published in one of their latest, let's say, studies about the energy management sector. Okay. So the companies that we are offering similar services than Dexma, so Dexma and its competitors, we all started working with sensors. Okay, so we had those sensors in the field, Modbus, Mbus, whatever protocols and technologies, and we were just getting the data from here. That was maybe at the beginning of 2000s. Okay, then we started to think about, okay, what do we do with that data? Let's apply some analytics layer on top of that. And why not? People love dashboards. So let's show them the data in a dashboard fancy way. And that's what normally our competitors offer. Okay, so they are spectacular. They have good platforms to show you the data. But that's not enough. If you want to go farther and you want to offer more value and you want to be the best energy services company, you need to go and offer more value to your end users. And that's about models. Okay, so you have to model your energy consumption to detect when are you exceeding that expected consumption or not. That's something that you will see today. You need predictive models and you need artificial intelligence to analyze your data. Just as a number, if you have, let's say, 1,000 data sensors reading from the field every month, you have millions of readings that you need to analyze. Or you do it by hand, or you hire like 10 different engineers, or you have a machine that it's intelligent enough or smart enough to detect what's going well and what's going wrong in your project. Okay. And then, of course, the future of all of this, it's about real-time optimization. So working in the demand response market, taking price into account and many different inputs to, at the end of the day, optimize your cost. Okay. So for us at Dexma, artificial intelligence is seen like as a good opportunity to differentiate us and to provide you guys, our partners, superpowers, so you can deliver the best services as possible. Okay. So, well, that was my part. It was short, right? But because today the main focus is about letting Juan and Uriol explain you about these artificial intelligence fancy keywords, normally are buzzwords like, okay, so let's do it. Everyone seems to be doing artificial intelligence, but today you will see what it is really and how we are solving problems, real problems with artificial intelligence. So let's give them the word so they can explain you guys what is that about. Okay, Juan, so here you have it.
Thanks, Danny. Hello, everyone. So we're going to explain a little bit what's the artificial intelligence. Basically, that's why you are here. So we're going to explain that, but everyone heard before what is artificial intelligence. So artificial intelligence, it's a machine that can make anything, learn by itself, it solve any problem that you have in your life. Okay, wait a minute. That's
not the reality, right?
That's not the reality. We saw that in the films. It's cool. You see that it learns by itself. It do a lot of things, but that's not reality. The reality is that artificial intelligence is a mix between science, computer science, maths, EOT. So basically, the term of artificial intelligence is applied when a machine mimics, and that's an important word, mimics, cognitive function that humans associate with other humans' minds, such as learning and problem solving. So remember the word mimics because we need some data to learn from. It cannot learn by itself. It cannot do anything like magic. No, we need something to mimic. So we need data, and we need somehow to have a metric about how good is learning or how bad is learning.
So Juan, for the ones that we are not really habituated to that concepts, it would be like a baby that starts learning during its life, right?
Well, exactly like that. So in the beginning, when a baby is trying to learn, it takes something, it just drop and has to learn again. Okay, now I have to take it like this, and now it works. So basically, a computer is doing the same, but with data and much faster. It don't need 1 year to learn how to do something or 3 years to work. No, it can do it in seconds. So that's the powerful part of the artificial intelligence. So here we have a small video. We are going to try to make you an example about how you can learn. This is Mario. I think you all know what's Mario about, and it's going to be our well a machine learning, and artificial intelligence is going to learn is going to learn about how to play in real time. So what we're going to do is to let it play. Basically, well, we didn't do that. It's a video on YouTube. So basically, what it's going to do is going to play a lot of times to this. So if we can stop it here, I'm going to explain you here what we are looking. So in the upper part, in the left part, you see here, this is what Mario see. You see this, the white parts are the parts that are static. And then the black dogs, let's see, yeah, you can see that one here, are the animals or the ones who want to kill you. So that's the input. And beside that, uh, here we have the outputs, are the buttons you can press. You can go right, you can go
With
left.
the commander, right?
Yeah, like we were playing when we were younger. So the idea here is that with this input, this uh, artificial intelligence in between is called neural network, can decide what to do. So basically, what it's going to do is as well as we did in when we were younger, you start to play, and then uh, we'll see here. So in the beginning, it's going to be very bad. It's going just to go right, and it will never win. Of course, it's just going to try, and it's not going to win. So try again, trying different things. And the important part, this is the data. Just to play is the data, but the important part is also the metric. We are trying to play as good, so the score goes high.
Higher.
That's the important part here. So the idea is we play a lot, we have a lot of data, we have metrics that we want to optimize, and then the algorithm just try to fit that. This is a function.
Okay, so it's as easy as repeating the same thing, making some changes, trying to learn. So the algorithm tries to learn, understands which buttons has made in which iterations, and then if the score was higher than the previous iteration or not, isn't it? Right. So
The good point here is is that it's a good example to see what's going on behind the walls. At the end, we are seeing the complexity of the neural network. It's increasing during the time. Now the machine is using all the possible operations and not only walk to the right side. So
so pressing A, B, so on, right?
So here, just to finish this example, we can see how it plays in the end. So it's going to go so fast and it's going to go good. So it basically learns not sometimes, and usually it's like that, better than a human. It's still learning. It doesn't play, but in the end, in the end of the video, you can just see how it wins. So artificial intelligence can be even better than a human. That's the idea, and even better with that than a human. And of course, it's going to be faster. That's the key part here. So I'm going to put another example here. This is more real life function of artificial intelligence. This is not neural networks. It's type of neural network. It's a convolutional neural network. It's called YOLO. You only look once. It's funny.
That's good.
That's the name of this algorithm. So basically, what we do is a classifier of what is seen by a webcam. So this is how if we stop here, you can see how it recognizes his person, his motor vehicle, and here it says a container. Okay, it's not, but it's doing it on real time. That's the important part. It's very difficult to do that. It recognizes where persons are, where cars, it's everything. And with this is how Tesla or this type of companies make the vehicles that drive by their own.
Yeah.
So
Like a self-driving vehicle.
yeah. So the artificial intelligence is here, and the artificial intelligence is not magic. It's just maths and data and metrics. That's the idea we have to present here. And I hope you guys get a little bit of this idea with these videos. You have it. We will can send you these videos if you need it. So just I hope you enjoy that part.
And now we are trying to show you real examples, in our case, applied to the energy consumption or the energy world. And at the end, the idea is apply this math and science, trying to solve day-to-day problems, providing you some metrics or some extra information or added value information to help you to decide or to compare different options that if you have to do it by hand could be more difficult or could need a lot of time, and we have not enough time to test anything. So at the end, the idea is we are trying to help you to do some things faster and comparing different scenarios using the machines and the data that you are providing to our solution or to our software. At the end, this is the first example on we are applying machine learning. In this case, is a functionality that is available on our software, on our platform. You can use it and you can test it on your own buildings. This is a forecast, a prediction model or a prediction function that provides you the expected behavior of your buildings for the next year. It's updated every day, so every day you can know the expected behavior and consumption for the next year. And it's very useful if you are trying to plan or to decide or to evaluate or define budgets. So you can estimate the cost of the energy for the next year, not only for a building. If you are applying it on all your buildings, you can have an estimation of the next year budget for all of your portfolio. And as a summary, we are using different features or parameters to calculate this forecast. We are using the day of the week, the month, the hour. At the end, we are using the time details that we have. We are using weather information, in that case, heating and cooling degree days. At the end, these two parameters are very related to the HVAC or air conditioned systems. So we are using it on the model, and we're using the temperature of the location. At the end, this is helping us to apply a model on different weather zones and provide a good results for every part of the world.
So, Oriol, what we are saying to our audience is that basically we learn from our consumption, our self-consumption based on these features, right? The week, month, hour, heating degrees, cooling, and temperature. And then we are providing every night the 360 consumptions in advance, right?
Yeah, at the end, we are using the data that is available, and we are putting it on a model, on a machine, if you want to say that. And then you can provide you the result forecast or the expected behavior or consumption on a future.
And could you maybe show this to us?
Yeah.
So, okay.
At the end, we can show it, but this is, we are now seeing our platform. This is the Xcel Energy Manager. In this case, we are in the apps market. It's a part of the software where you can install additional features to the product, and you can apply it on your buildings. In this case, we want to add the forecast feature to our portfolio, and you can install it here. And then this is the way that we are providing you the forecast results. We have two parts. At the top, we are providing a metric. The idea behind this metric, it's we are saying if you can rely or not on the forecast. At the end, this is not magic. We need data to provide you forecast. So if your data is good, we can provide a good forecast. If you have not enough data, or the data have some problems, outliers, missing data, or you are just starting a project, we need more time to provide you a good forecast. So we are here, we are showing if it's high, good, or low reliable, this result. And then you can see the forecast for the next year, and you can see the variation between days and weeks. And
Even it's cool that the system learns and applies you some kind of seasonality, right? So in summer here in that example, starting on June, July, August, September, the consumption goes up, mainly because of the HVC effect, right? And this is because we are learning from your previous year's consumption and as well from the weather conditions, right? So, and the fact that Dexma offers this reliability metric, it's different from other competitors, right, Juan?
Yeah, the key idea here is that we don't sell magic. We try to provide you a way that you believe in the forecast with something behind, and you need the data. So the reliability metric, it's something that help you in that, and help you to make your decisions based on maths, not on just belief. Okay.
Well, basically, we had tuned up this metric. It has three different levels: high, medium, and low. And we have tuned it according if our data science will make decisions based on this metric or not. So you are as well using part of our experience in that.
Here we can see the forecast for the next year in a cumulative way. That's just another way to see it. And then we are going to present you what is going to come. So here I'm going to present you the 48 forecast. Why is different? If we have already the 1 year ahead forecast, is because we need a little bit more accuracy. If we want to make the something like demand response or something like that, you need a really good forecast. And for that, we use math. So this is the algorithm. So we make discrete wave transform to separate the channels. Then we make LSTM, that is neural networks, and then we make the forecast, and then we make the inverse of the. Okay. So here is the idea, because I probably a lot of you don't know what LSTM, that means long short-term memory. The good news about this is that we take care of this. Okay, don't worry. You don't need to know nothing about this. You just need to know that we put the input parameters inside of this box here, this Dexma AI. It's the neural network. It's called LSTM. Fancy words. You don't need to know nothing. We have this day of the week, month, hour, historical consumption, real-time consumption, and then we provide you the 48 hours forecast. This was an example. The green part is the past. The white part is the future. So the red line is the forecast, and the real consumption is on blue. So here you can see that, of course, we have some difference between the forecast and the real consumption. And of course, we have more accuracy in the next 24 hours than in the next 48 hours. That's also probably because the forecast of the weather is not always not so good. So, well.
And at the end, the idea, we think that this forecast can be very useful for demand response, for net zero energy buildings, and at the end to be used as an input for optimization models or softwares that can manage storage, renewable energy, and the consumption of the building. So at the end, this is not only a result. This can be used as an input of other models that can provide you real-time control of your buildings.
Exactly. So from the energy market sector, what it's going to come, it's the net zero energy buildings. Well, in 2019, in many countries in Europe, will be in place like European legislation where new buildings and the retrofit ones needs to be nearly zero energy buildings. So that means that you have plenty of assets into your buildings that you need to manage somehow, right? And we are already developing this technology to help you on that. Even you can add here as an other input, you can add the cost of the energy in different hours of the day, right? So the wholesale markets are arriving to many of the countries in Europe, mainly, right? So the system uses those inputs to optimize your production and your consumption, and then as a result, to optimize your bill. Okay, that's cool.
And now we want to show you another feature that we are working on. At the end, this is a baseline. Sometimes we can be not so sure between the difference of forecast and baseline. At the end, forecast is something that you want to estimate exactly the consumption for the next day, the next week, the next year. And on the other hand, the baseline is a model that provides you the expected consumption of your building if you don't do nothing on there. But it's very useful if you want to evaluate the savings of something that you have changed. If you have applied some recommendation to the building, you have changed something of the installation, you want to know the savings that you are being providing. Yeah, you want to evaluate the impact of your work on the building. So this is the idea behind the baseline, and we are showing here a tool that is able to provide the best baseline for your buildings, evaluating a lot of different models and providing you metrics to decide if this is the best or if you want to tune it and provide a better solution or better understanding solution for your clients.
So while Uri is preparing the demo, well, this is basically what you need to have. So if you guys are an ESCO and you are performing energy services contracts, then you need to place in the contract a formula, right? So this feature, as Uri will show it to you in the next minutes, it's intended to be as fast as hell to calculate that formula for you.
Well, the idea here is that if you are used to make this baseline by your own, you know, you need to know a lot of things. You need to know how to calculate linear regression. You need to know, well, you have to take some decision. Is this decision, is this variable representative? How many do I use? Is this good enough? That's the idea that we are going to solve with this feature. That's what we solve already. So it takes normally 30 to 45 minutes to do this for experience. For experience engineering. So thanks to automatic learning, I press a button and in 30, 45 seconds, not minutes, seconds, you can have a baseline. That's the easy part. That's how you get value from artificial intelligence. And it's easy and it's fast. So now I present you here very, very fast the parameters we use, the heating, cooling, degree day, occupation, and production. You can put as many as you have in the Excel. So it's not only that, if you have another ones that you can use in this baseline calculation, you can do it. And the idea here also is that as many parameters as you want and as many iterations between them, you can make them on 35 seconds. So in the example we're going to do, it's going to be more than 1,000 millions. Yeah. So just to have you an idea of how fast it is. And it finds the best that fits you. You don't need to know nothing, and it will do it automatically. So please, Uri, can you show us?
Yeah. Now we are trying to show you the feature in a in a demo. Sorry. Now this is a feature that we are working on. It's not in the Excel right now. I think that will be available in the next year. But now we are going to our developing platform. We can show you the performance of the solution, and we are using real data from the Excel, but it's not the feature available yet on the software. So at the end, the idea here, you can select the building that you want to analyze or you want to calculate the baseline. Here, sorry, we are going to select a building. And then we are putting it on a map. We can select the weather station that we want to use to provide the weather information. Here we are using the closest one. Then we want to create a baseline or a formula for the main consumption, the active energy main consumption of this building. And then
we could choose anything that we want.
yeah, if you want to provide for
thermal.
gas, for water, for photovoltaic generation, you can provide or create a baseline for any data or any parameter that you have in the Excel. And here the idea is, and on the left you have the weather parameters that are used from a virtual or for a weather service that we are providing to this tool. But if you have weather data on the Excel, you can use it. So here we have a weather station. We can add cooling and heating degree days for our custom weather station. And we can add different parameters, for example, the day of the week, or if we want here the month, or if you want to use exponential of the parameters. And here in this section we can see the number of parameters that we are using. If we use exponents, we have the double number of the parameters. Here we have advanced options. For example, we can evaluate different levels for the cooling and the heating. So we can put it on 17. Then we have more parameters to use.
So in that way, the system is going to optimize, which is the heating and cooling best base temperatures, right? Okay, that's beautiful. So far we have been selecting all the inputs for the system, right? And now we have selected all the 2017 years, so from the 1st of January to the last of December, and we have clicked on the monthly because we want to get it monthly. So now the system it's making all of those iterations, right, guys?
Well, the idea here is not only to make a regression, we also have, because the regression is not artificial intelligence, it's not machine learning, it's not nothing special. The way that we select the features is that the way that we have artificial intelligence there and we have machine learning. And it makes it selects for you the best parameters that fits you in a let's say classic way of verification, you know. And we can do that also daily. That is more important. And the idea is that you can do that with your own data. And we see that is very important here. You have here the formula that you can put in your contract, and also you have here the metrics. As always, we talk about metrics. Here you have the R square, you have the R square adjusted, you have Bayesian information criterion. You can have all the ones you want. Something more?
Yeah, and if you want, you can compare it with your own baseline. So you have one, you can put it here, and you can compare it. And you can work with different baselines, compare. Here you have the difference between the metrics of the automatic baseline and your own baseline, and you can decide between them, or you can remove one of the parameters for the automatic baseline, and then you can, at the end, you can play, and you only need some seconds or some minutes to compare a lot of different models and decide.
And these guys, at the end of the day, helps you to reduce the amount of effort needed to generate baselines, but as well to reduce the risk on your contracts, which is far more important. Okay, so you have the data, then you have that kind of tools that we are developing here today to help you with that and help you to be the best energy managers in the market.
So the next feature we're going to present to you is something that we are very proud of, is anomaly detection. So what we are going to do is to explain you, well, you know how to find anomalies that makes you to save money in the end. You know, so when you find these anomalies, you can change them, you can turn off whatever is making the consumption, and you have to. Right now, you do that with evolution tool. You compare in the past. Oh, I did this, I did other thing, and then okay, here is a difference. I will do something with respect of that. Now, what we do, that takes you time. You have to do it by your own. You want to put the time. You want to compare. So the idea, yeah, here you find the anomalies. So the idea is what? but what if the artificial intelligence will help us? So here we have an example of anomalies detected by artificial intelligence. You see the red part is the anomaly, the bad anomaly, so your consumption is more than expected, and the green part is the anomaly that is good. It's good because your consumption was less than expected. Okay, we do that in a very fast way, and you can do that for six, for example, or well, you can do that for a lot of them.
So the idea here is to scale. It's to scale yourself, right? So as a human, you cannot analyze more than, let's say, 1,000 sensors per week at maximum. That's a superhuman almost, right? But with machines, we can do it thousands and thousands of times, and not just once per week or once every quarter. We can do it once per day, even, right? So the platform learns from your consumption and then understands what's an anomaly and gets the feedback from you from the energy managers. So you just focus your time in the anomalies that really add value to your customer instead of just analyzing hours and hours of data that it's meaningful. You just focus your time and adds more value to your contract. Okay.
Well, so we present you the same as before, the input parameters for this artificial intelligence algorithm that work to find the consumption you should have in the previous days is day of the week, month, hour, heating degree days, cooling degree days, temperature, and here we can also use historical load because it's not for verification. You can use that, and with that you find the anomalies you had in the previous month, previous week, whatever you want. So you can just in some seconds you can just have an idea how your building worked. If you have to just say to okay, you have to turn off the HVAC, it's just on during the nights. So I'm going to make a demo right now. uh, so let's see if I can find it here, because we also have another well, it's still not on on the Excel. We will have it, I don't know when. That's something that Danny don't allow me to say.
Well, that's going to be like a spoiler, right? So we do prefer to keep it hide, but stay tuned because that has been demonstrated a good value for our partners so far. So we're looking for people that wants to try this into their project. So if you guys have some data and you want to run this algorithm detection engine on top of your project, just tell us that we can work together.
So here you see the demo. So basically, we choose a building that was is in Dublin, and we choose these days because it's so funny. So we found some anomalies. The red ones, okay, was a peak in consumption. The machinery was going bad, and then make a very big peak. Here you see it, the consumption is much higher than it's supposed to be. And also on Friday, it was Thursday and Friday that was a little bit crazy for them, and then well, that's money, and you have to call and say, okay, what's happening here? But what also is very very funny is that okay, here they save a lot of money. It's supposed to be a consumption here, but the consumption was very low, and we were a little bit surprised. We were not expecting that. Are the algorithms going bad? And well, it was a Friday that the company decided just to close. So of course, you also that's an anomaly. You have to decide as your work guys to decide if this is an anomaly that you want to repeat or is just something that is not expected. So if the company close, well, you save money, but you cannot make that more days. So, but it's funny that or yes.
Depends on the human resources team, right?
But it's funny that we also find that and we call them and say, yeah, yeah, that's anomaly because we close. So that's how it works. You here have the number of bad inefficiencies. You have here the number of good efficiencies and the cost. Okay, in this case, the good efficiencies, as says, because of this part is much higher. And also you have the some, well, resume here about the hours. It was worse because perhaps you always have uh, anomalies in the beginning of the day or in the end of the day, or well, that's this part is what you have to analyze, but you can do that in seconds.
Again, this is a feature based on artificial intelligence that we really believe that will disrupt the market because it will change the way how energy managers work today. So instead of analyzing all the different curves, maybe Juan choose another week and we could see what happens. But so instead of just going there and analyzing a period of days, the system could be proactive, right? So the system could be sending you a report with the top anomalies that happened in a particular period. So now we are seeing like 4 weeks, right? And we have detected 350 euros in anomalies. Okay, we have.
If you give me Danny, yeah, here you can see how in the night, in this particular part, you can see that during the night was a big problem here because something was on from at 9 someone just put on something and then it was the whole night consumption. So here you have an anomaly, you can call someone to say, okay, this cannot happen again. That's the powerful of this tool.
And you know how much it cost, right? So you can make decisions based on the absolute cost of that anomaly, right? We have anomalies with higher costs. We have anomalies with lower costs. You could tune up the system just to report the anomalies that they have reported less than, let's say, 100 euros. So in case that those are not interesting for you, or you can tell the system, just let or give feedback to the system, like telling this is not an anomaly, this is the normal way. So the system learns from you and from your feedback to make it better and better for every time that we have more data. Okay, so I think that it's time for questions, more or less. Yeah, so we are the three of us here waiting for your questions. So just write into the box next to the next to the GoToMeeting box. You have a questions box, so you can write there whatever you need to know, and if we can answer it right now, we will do. Otherwise, we will reply you by email in case that we don't know the answer, because this is like a very wide tema, right? Well, we have a few ones. Whoa, that's incredible. Okay, so first one: does the ABC calculate the potential savings by installing or using future assets for self-consumption? If not, does any other Dexma product does this? Uriol, could you maybe answer this question?
Yeah. ABC it's not calculating it, but ABC could be used to evaluate the savings that you achieve after you install these self-consumption assets. But on the other hand, we have another product that it's Energy Grader, and on Energy Grader we are working on a library of recommendations, and some of them are self-consumption or batteries or different recommendations that are evaluated, and we can provide you metrics and financial KPIs to evaluate if some of them could be useful or not for your buildings. So the answer is yes. We have it not in the ABC, but we are working on the other product, the Energy Grader, and it's able to evaluate it.
Good. So
but if you are interested on that, we can talk in detail through the email or.
Yeah, so in the screen you have all our emails. So just take a note from the Uriol's one, and if you have more doubts, you can just contact him. Okay, we are very open. So next question comes from it's from Rob. From Rob, yeah, we manage several hundred multi-unit residential buildings. We don't own the buildings. Okay, we only have utility bills in hard copy. Where is the best place to start? Okay, so that's maybe from the Energy Grader again, right? So we offer. That's a shame because we haven't shown this today. But and anyway, so the grader, it's like a machine that detects which are the best buildings to approach in terms of energy efficiency, because it calculates how much efficient you are compared versus the other. So Rob, I will contact you during the next days. Okay. There is full of bunch of questions, so thanks for that. Which one we can answer, guys? Are you able to incorporate occupant activities as a variable, presumably provided by property manager, or not? That one.
Yeah, of course. I mean, if you have any kind of data that it can be provided, but manager or however you take it, and you can put it in Xcel. We can put it in our algorithms, and we will take it in account of that. So of course we can use more variables. Please just put more variables, and the algorithm is going to be much better. It will say to you if it's representative or not. But of course we can use that part.
We have some questions related to demand response. We have talked about that during the webinar.
Yeah, but very few maybe.
Yeah, and at the end, the idea is we are working on demand response. We are on different or several R&D projects, and we are developing a prototype for demand response for automate the behavior and the control after a demand response request. So yes, it's not on production, but we are working on there, and it's probably that we will work on the during the next year. So if you are interested in that, we can contact us and we can talk about that.
Here,
The other question that we have, it's about what's the major difference in between manual and automatic baseline calculator? Wow, that's a good question, right? So maybe the time, or
well, there is many difference, but first of all, with manual, you need to know what you are doing, and you have to know it very good. So sometimes you don't get the whole powerful of your data. With automatic building calculator, you don't need to know anything about math, and you still can do the best baseline that
ever.
well, ever. You can make the best. Second one is the time consumption. The time you can do it much faster. And third one is the iterations between variables, or the optimization of the temperature. So when you make heating degree days or cooling degree days, you need a pivot temperature that you say, okay, this is a heating degree day. You can optimize that for your building. It's not the same the building that works here in Spain that another one that works in Finland.
However, I think that the good thing is that the result can be auditable. So you don't have to trust like God that this is the good formula. So you can get the results, you can extract the results in Excel, and you can audit the results that the system provided you with your own tools. That's how the IPMVP protocol works, right? And it says in the protocol that should be auditable. That's why the ABC application works in that way as well. We have another question. That's a good one, maybe for Juan, and it's going to be the last one. Okay, and the rest of the questions will be answered one by email. It was regarding the artificial intelligence. Okay, hello. I want to ask you a question for the Dexma artificial intelligence. Are you implementing machine learning algorithms on your own? So, guys,
Well, that's
tell the truth.
yeah, that's a tricky question. We program them on Python, and we use some already made libraries, but we also make some of them by our own, or at least we try to tune or to use different, for example, as I show you, the discrete wavelength transform combined with LSTM, and then this kind of thing. It's something that, of course, that's the hard part, to just make it not to know what you have to do and use it in a correct way. We don't make the LSTM by our own. That's not our business here, but we use it and we put it together and make our own algorithms for that.
I think that as a summary, we are using developed algorithms, but we are creating our own models. So at the end, our models are developed for ourselves, but we are using algorithms. Some of them have a lot of time that have been developed, but our models are developed from Juan and from me, and we are using our data to improve it.
And more important thing also is that these models normally are not usually applied to energy, and we just change them, and we change them in the way that it fits to the energy solutions. So that's our work here.
Okay, so I think that we can conclude this webinar here. Thanks so much. Have a Merry Christmas to all of you. So it's the last webinar that we did this year. We have done like 20 or 25. So next year we will do the same amount or even more if we can. So stay tuned in case you like it, because we are enjoying so much making them and preparing them, right? So all the I don't know. I'm just counting here. Like, we have 20, 25 other questions still to answer. So we will send it to you. We will answer myself, Daniel, or Juan, or Uriol in person. Okay. So we are on the same page and you can solve all your doubts. Okay. We believe that artificial intelligence is going to make the change in the future. That's why we are here and that's why we are working on that. Right, Juan?
Yeah, that's it. Thank you, everyone, and just keep sending data. We will make the best model with that data to provide you the best solution.
Okay, guys. So see you next time, right? Happy New Year and Merry Christmas as well. See you. Bye bye.